Alhamdulillah, this slope deflection method. So I'll share the slides. So is it visible to you, the slides, students?
Yes, sir.
Okay. So this is the second topic we are going to start, that is moment distribution method. The first one was slope deflection method. It is also come, this method also comes under the category of displacement method. So if we talk about this moment distribution method, this is the second method we are covering under the heading of displacement method. Whereas force method you have already covered with Dr. Yusuf. What this method states, how it operates, how we can solve any indeterminate structure with the help of moment distribution method, we are going to inshallah cover it today's lecture. This method was originally developed by Hardy Cross in 1930. This was the originally founder of this method who developed it. So at that time, it was the very first method for the analysis of indeterminate structures. So that's why it took the attention of all the field practicing engineers, and they started analysis on this part. What this method do actually? This method is a basically method of successive approximations. How it deals, how it transforms, or how we do the analysis within this method. It goes like that we go the certain approximations by considering that initially our joints are fixed, that the structures, each joint is initially fixed. Let's say, for example, if I draw a beam, continuous beam over here,
एक्सक्यूज मी सर.
जी.
सर आई थिंक वो आपने बोला था कि फ्रेम का जो स्वे केस है उसका शायद लेक्चर मैं रिकॉर्डेड अपलोड करूंगा, तो वो शायद अभी तक आपने नहीं किया.
ओके, मैं विद इन दिस वीक वो भी
सर
आपको
वो
करूंगा।
नॉन स्वे वाला केस किया था ना, बीम की एग्जांपल और नॉन स्वे फ्रेम की एक एग्जांपल हमने की थी, तो उसके बाद
ठीक हो
स्वे
गया,
वाला शायद.
ठीक हो गया। आई अपलोड दिस वीक इंशाल्लाह, और उस पर अगले वीक में डिस्कशन भी कर लेंगे अगर आपके क्वेश्चन हुए तो।
ओके सर, थैंक यू.
ठीक हो गया, नो प्रॉब्लम। अच्छा किया आपने बता दिया। बल्कि सो we'll go by this, that there are number of multiple spans over here. Initially we consider that our each joint is fixed. We consider that its both ends are fixed, something like this. So initially our first assumption is that every joint of the structure, they are fixed. So we are considering it as they are logged actually. So then what we do, we unlock the joint and we distribute whatever the moments are here, whatever the moment at this joint, whatever the moment over here, that will be distributed to the span now. Again, once we distribute the span, we again lock the joints. So once moment is distributed, then again we unlock. So it means it is basically what we are doing. Initially we consider that this joint is locked. Whatever the moment we can find out through fixed and moment formulations. We have the formula to find out any moment on the ends due to the applied loads. So once we have considered that moment is there, we distribute it to the side spans, how much can be taken by each span. And then we again consider that our moment or our span is, or joint is locked. And in this way, by unlocking and locking each joint in succession, the internal moments are distributed and balanced. This is important, that we distribute and then balance until we find out that how much a joint can rotate, how much it can rotate to their final or nearly finally position actually. So this is a simple way of explaining it actually. But once we will solve its example, it will be more clear to us that how this method works. But initially we consider that our joints are fixed, then we release the moment or we distribute the moment from the joint to the spans. So this is how it goes on. Sign convention for this moment or this method is that the clockwise moments are positive. This is what we have already done in our slope deflection method. Then What is the fix and moment? Anybody who can tell after working on slope deflection method? अगर कोई बता सकता है तो any one of you who can tell me that what is this fix and moment? Anyone? Nobody is there who knows that what is this fix and moment? कोई नहीं बता सकता जी?
सर जो मतलब दोनों एंड से फिक्स हो, जो स्पोर्ट्स दोनों स्पोर्ट्स से.
Just give me your attendance, then I'll move on. From where, which roll number you start?
Sir 56 roll number.
56. Okay, 56. Roll number 56.
Yes, sir, present.
बेटा आपका नाम क्या है?
Maliha Rasool.
Maliha Rasool. Roll number 57. 58. 58. Roll number 58. 59.
Yes, sir, present.
बेटा नाम क्या है आपका?
Sir, Hamama Ali.
एक्सक्यूज मी सर.
जी जी
सर वो कुछ स्टूडेंट शायद वो प्राइवेसी लगी हुई है तो उनका ज्वाइन नहीं हो रहा, वो शायद आपने एडमिट करना है तो फिर जो है वो ज्वाइन कर सकें.
कर दिए मैंने.
ओके सर, थैंक यू.
रोल नंबर 60. रोल नंबर 61. 62.
61 present sir.
जी बेटा क्या नाम है आपका?
फरीहा निसार.
फरीहा.
जी सर.
ओके बेटा. रोल नंबर 62. रोल नंबर 62. 63.
Yes, sir, 63.
जी क्या नाम है बेटा जी आपका?
Saliha name.
64. 65. 66.
Yes, sir. Present 65.
65. What's your name, beta?
Jayani Pereira.
Jayani Pereira.
Sir, my roll number should be R65.
R65. Okay. 66. 66. Roll number 66. 67. 67. क्या नाम है बेटा आपका? जी हमजा. ओके. 68. 69.
68 present.
68 आपका क्या नाम है? जी
अयान इकबाल.
रेहान इकबाल.
अयान इकबाल.
अयान इकबाल. ओके. रोल नंबर 69.
Present sir 69.
जी क्या नाम है आपका बताइए?
अब्दुल हसीब.
अब्दुल हसीब. ओके. रोल नंबर 70.
सर रोल नंबर 70 प्रेजेंट.
क्या नाम है आपका जी?
जवाद अहमद.
ओके. जवाद अहमद. ओके. देन रोल नंबर 71.
Yes, sir. 71 present.
क्या नाम है बेटा जी?
Hassan Ali.
हसन अली. 72.
Yes, sir. 72.
जी
Farhan Khalid.
फरहान खालिद. 73. 74.
Rather, sir.
जी जी क्या रोल नंबर है? 74.
74.
जी क्या नाम है आपका?
राकिब अली.
73 सर, कमर हबीब.
कमर हबीब. 74 आपका क्या नाम है?
सर राकिब अरूज.
राकिब अरूज. ओके. 75.
सर 73 कमर हबीब.
जी जी लिख लिया आपकी. 74, 75, 76.
Yes sir, 76.
नाम बताते जाएं जी अपना सारा।
मोहम्मद उमर परवेज।
उमर परवेज। 77,
Yes, sir. 77. Shamsur Rahman.
शमसुर रहमान। 78, 79,
79 मोहम्मद अनीस।
मोहम्मद अनीस। 80, roll number 80, 81,
यस सर 80 हसन सजाद।
हसन सज्जाद।
सर रोल नंबर 80।
जी जी लिखिए। 81, roll number 81, 82, 83,
यस सर सर 81 फैसल हमीद जी।
81 फैसल हमीद। ओके।
यस सर।
82, 83, 84, 85, 86,
Yes, sir. 86.
Yes,
Mubin
sir.
Hussain.
84. Moin Awais.
84 क्या नाम है आपका?
Moin Awais.
मोइन अवैस। 85, 86 कौन था?
86. Mubin Hussain, sir.
ओके बेटा। 87,
यस सर 87 मोहम्मद उमर फारूक।
87 उमर फारूक। 88,
Yes, sir. 88. Hassan Iqbal.
88 हसन इकबाल। 89, 90,
यस सर
90,
90 मोहम्मद बिलाल।
90 मोहम्मद बिलाल। 91, 92,
Yes, sir. 91. Muhammad Mohsin.
मोहसिन। ओके। 92,
Yes, sir. Mohammad Hussain 92.
हुसैन। 93, 93, 94,
ऐसे
95,
मोहम्मद सरफराज 90 मोहम्मद
90,
सरफराज 94।
94 मोहम्मद सरफराज। 95, 96, 97,
Yes, sir. Yes, sir. 96 Usama Rashid.
97,
Yes, sir. Amish Bashir 97.
97 आपका नाम क्या है प्लीज बेटा?
Amish Bashir, sir.
आमिश। ओके। 98,
Yes, sir. Mohammed Sham 98.
मोहम्मद एहतिशाम। 99, 100, 101, 102,
Yes, sir. 102 Naveed Abbas.
102 नवीद अब्बास। 103,
Yes, sir. 103 Muhammad Uzair Shafiq.
104,
यस सर 104 उसामा अरशद।
105, 106, 107,
सर 104 तक ही है।
ओके।
बाकी मे भी कोई रिपीटर वगैरह अगर हो।
अगर anyone
सर शाहजेब 85।
जी
85 शाहजेब।
85 शाहजेब। anyone
एक्सक्यूज मी सर।
जी जी
सर
बेटा।
58 का माइक काम नहीं कर रहा, उसने चैट में लिख दी है, काइंडली उसकी अटेंडेंस मार्क कर दें।
58, okay, I'll see.
Excuse me, sir. 290.
290. What's your name, beta?
Fatima.
Fatima, okay.
83.
83, 83, what's your name? 83, what's your name? '83, are you there? Okay, I'll start with the lecture now. Now, I was asking that you have done this in your previous, we have covered it, that what is the fix and moment. So can anybody define this fix and moment? I have your roll numbers and name. Now, roll number 69, Abdul Hasib. Can you tell me what is this fix and moment? How we define it? No. Roll number 74. Roll number 74.
Yes sir.
Can you
सर
tell me what
मतलब
is this?
जिनके दोनों स्पोर्ट्स फिक्स हो
Okay.
और वहाँ पे
No,
फिक्स मूवमेंट
the fix and moment is actually moment due to applied load on the two ends. This is one moment which is being generated over here. Another moment at this end. Due to this, any type of load present in the span. Either the span is UDL. So we find out these two formulations, these two moments. And in slope deflection method, there are formulas given to us to find out these moments. So you have calculated in the slope deflection method these fixed end moments by the certain given formula in the table. So this is how we define that this is the fixed end moment. This depends on the type of loading. Either it is UDL, UVL, point load, any of the type of loading we see, and then we find out that this is how we define fixed end moment. Is it clear, class, or not? Is it clear?
Yes sir.
Yes, sir.
That how we define that this is our fixed end moment. So this is the moment which is generated on the ends of the beam due to applied load. And this is typically depends on the type of loading. Roll number 68, can you redefine it again now?
Same moment due to the applied load on the fixed joints.
Very nice, very simple, and we have calculated them in our previous example. So I'll move to the next part. Then comes member stiffness factor. Now, before going into the discussion of member stiffness factor, I will ask you, you have already calculated the flexibility factors. Can anybody find what is flexibility? In force method, you have calculated it, or we have already done it. कोई है जी जो बताएगा? Anyone? 67, Hamza Niaz. Can you tell me what is flexibility factor? Now, this is basically displacement generated due to unit applied load. And its reverse is actually stiffness factor. That it is the amount of moment required to produce unit deformation. So if we see that it is defined as, stiffness factor is defined as the amount of moment required to rotate this end A, width of the beam equals to theta A equals to 1 radian. So it means if I want to rotate this deformation equals to 1 radian, I want to rotate it to 1 radian, the amount of moment I need, this moment I need, that is called as stiffness factor for any particular structure. Now, this relationship we have calculated in our slope deflection derivation, very first relationship. So if we see that this is a simple single degree of freedom structure, we have applied moment over here. So once due to this moment, there will be a certain rotation over here. And there is also one moment at this point. If we find out the relationship between this rotation and moment, this comes as m equals to k of theta. So this K value over here, that is equals to 4EI over L. Once our far end is fixed, remember, this is very important for us, that once our far end of the beam is fixed, this far end is fixed, we have this fixity over there. So this formula or the stiffness factor is equals to 4EI over L. So this is called as stiffness factor. So there is one more example. There are two possibilities with us. Let's say if the beam has one more far end, either pin or roller. If our far end is pin or roller, then this stiffness factor will be equal to, this K value will be equal to 3EI over L. So our stiffness factor will be 3I over L once our far end is hinge or roller. So this is how we define this. These two should be very well clear to us, that if our far end is fixed, our K value is 4EI over L. If this far end is not fixed, it is a pin or roller, our K value is 3EI over L. So these are the two cases for the calculation of stiffness factor. Is it clear?
Yes, sir.
Okay. So now joint stiffness factor. The next term is joint stiffness factor. So this joint stiffness factor can be calculated by simple principle of superposition. Let's say this is joint A with us over here. So how many members are connected with the joint A? This is one member, two member, and this is third member. So these three members are connected at joint A. So the joint stiffness factor will be sum of the individual stiffnesses coming from these three members. If I say here the K value will for the joint A, it will be equal to 1 plus 4 plus 5. So the total stiffness of the joint will be equal to 10 kilonewton meter. Is it clear to you or not, class?
Yes, sir.
Is it understandable or not? समझ आई है जी कि नहीं? Class, is it clear to you or not that what is this joint stiffness factor?
Yes, sir.
This is very simple. If I ask you now with this example, let's say, so we have four members over here. Let's say the stiffness for this member is 1 kilonewton meter. This has member stiffness here as 2 kilonewton meter. This has 5 kilonewton meter, and this has 6 kilonewton meter. Let's say. So what will be the joint stiffness of this interior joint? Can anybody tell me?
14.
14. So we'll sum them up. We'll add all the values. 6 plus 5 plus 2 plus 1. So the joint stiffness factor for this particular joint is equals to, K value is equals to 14. So this is very simple if we want to calculate it. So we have number of members connected to that particular joint. Whatever is the stiffness of each joint, we will sum them up, and that will be the total joint stiffness factor. Then comes distribution factor. This is very important term with respect to moment distribution method. What is this? So let's say we start with this moment applied at point A over here. So this moment will be for sure resisted by the moment generated on this member, moment resisted by this member, and moment resisted by this member as well. So these three moments basically, so that this total M will be the sum of these three M's. So if we see over here, it's schematic diagram on the right side here. So this total M will be equal to the sum of individual moments generated on these three members. So once we go by this, we find out that value and we see that. So the total sum of the moment is equal to basically the resistive moment generated by each member, actually justifying, actually you can say qualifying or satisfying the equilibrium condition over here. That once we say that our joint is in equilibrium, it means total sum of the moment at this joint should be equal to the individual moments, actually the sum of individual moments. So how I can say that what is the moment that is distributed to this member, how much moment is distributed to this member, and how much moment is distributed to this member? Can anybody tell me? That if we want to see that how much movement will be distributed to this end, how much movement will be distributed to this member, how much movement will be distributed to this member out of total? Can anybody tell me? Class, are you there? Students, are you there?
Yes, sir.
Yes.
Yes, sir.
Okay, I'll start with one analogy. It will be easy for you to understand. Let's say, students, you have three students has 10 rupees, total sum of 10 rupees I have with me. I give number one student, let's say first one, 2 rupees. The second one I give 4 rupees. And the third one as well, I give 4 rupees. So this total amount of 10 actually being distributed to these three students with the amount of 2, 4, 4. So how much is the total fraction I distributed to one student? Can anybody tell me? It's very simple maths.
1:2:2.
So how much I have given to the first student? That
1/5.
2 by 10 actually. This is what I have given to this first student, isn't it? So the amount distributed to this student, actually second one, it is equals to 4 by 10. And the amount given to the last student, that is also equal to 4 by 10. ऐसे ही है जी?
Yes, sir.
समझ आई कि नहीं?
Yes, sir. Yes, sir. Yes.
So it means I have distributed that whatever the total amount divided by individual amount. So same is over here if you see. The what was the individual moment divided by the total moment. This is the distribution factor for each member. Remember, students, this is very important term which I'm going to tell you that what distribution factor is. This distribution factor is the moment on the joint. This distribution factor is the moment on the joint, and it is distributed to the adjacent members. So there are three members, 1, 2, and 3. So there are three members to whom we have distributed this total moment. So it means distribution factor is the factor through which moment is distributed from joint to adjacent member. From joint to adjacent member. So if we see that now, this total individual moment divided by total moment. So this M is actually, we know that it is equals to Ki theta. And this total sum is also equals to theta into sum of total Ki. So actually the relationship comes out to be stiffness of individual member divided by total joint stiffness. So this is joint stiffness factor. This is joint stiffness factor. Individual stiffness of the member divided by total joint stiffness of the member. So this is how we find out the distribution factor. Can anybody repeat the definition of this distribution factor now? Can anybody explain this now?
The movement on the joint distributed to that adjacent member.
बेटा आपका रोल नंबर
86.
86. Mubin. Okay.
Yes, sir.
Okay. Anyone else who can again repeat it? Thank you. Mom? What is your roll number, beta? 67. Very good, Hamza. Okay, anyone else who want to say something about it? I want, because it is very important term. It will be used again and again in your questions in moment distribution method. If it is clear here, then it is very easy to understand and digest over there. Okay, roll number 76, Umar Parvez.
Yes, sir.
बेटा आप रिपीट करेंगे इसको?
सर दी मूवमेंट ऑन दी जॉइंट जो फिक्स एंड की तरफ से और स्टिफनेस के लिए हम लेते हैं इसे
डिस्ट्रीब्यूशन फैक्टर है कि जो जॉइंट पर मोमेंट है, द मोमेंट ऑन द जॉइंट इज डिस्ट्रीब्यूटेड टू हाउ मच इट विल बी डिस्ट्रीब्यूटेड टू द एडजेसेंट मेंबर. So let's say we have total M over here. How much will be going to this member? How much will be resisted by this member? So this is how we will find out it. Okay, and it will be equal to stiffness of individual member divided by joint stiffness. Remember this. Is it clear, class?
Yes, sir.
Yes, sir.
Okay, so we'll move to the next part. So then is moment distribution method. We find out that how we find out the distribution factor. So it's very easy. The stiffness of this AD is equals to 1. This member has 4. AC has 5. So if I want to find out distribution factor for AD, AB, let's say, so this is equals to the stiffness of AB divided by the sum of the total stiffness joint. So we can find out that this is the joint stiffness factor for member AB. So let's say if I change the value, this value is 6, this value is 2, and this value is 3. So please find out, this is your classwork, please find out the distribution factor for all 3 members. I repeat again, find out these values again. Then you need to find out these values again. I will give you 2 to 3 minutes, then please find. This one is 3, 6, and 2. will be equal to AC will be equal to 2 divided by 11. And this last one will be equal to 3 divided by 11.
एक्सक्यूज मी सर
जी जी बेटा जी
सर वो स्टूडेंट है एक इंजीनियर बिलाल, वो शायद कह रहा है कि एडमिट कर दें मुझे।
ओके जी डन। नाउ व्हाट इज द वैल्यू 6/11 क्या आता है जी?
0.545.
545. What is 2/11?
0.1818.
0.18.
And what is this? 3/11? 0. What it is?
27.
27. So it means now you can find out distribution factor, isn't it? Now you can find out the distribution factor for any value. So now if I ask you students one more thing, that let's say we have applied moment over here as 10 kilonewton meter. There is a moment of 10 kilonewton meter. How much will be the moment within member AD, member AB? How much will be the moment that will be distributed to AC? And how much will be the moment that will be distributed to AD? Can anybody tell me?
सर वो जो फैक्टर्स कैलकुलेट किए हैं उनको 10 से मल्टीप्लाई कर देंगे।
Very beautiful. Just you have to multiply this distribution factor with the moment. So if I multiply the distribution factor of AB with this total 10, so you can find out the value. So 0.4 into 10, it will be 4. So similarly over here into 10, that will be equal to 5, and this will be equal to 1. So simple way to find out the moment that will be distributed to each adjacent member. Remember students, again I'm repeating it, I'm giving it to emphasize, actually you should remember that whatever the moment that is coming on the joint, that will be distributed to the adjacent panel, adjacent member, with the help of this distribution factor. You should remember this, that what is the value, what is the essence of distribution factor. Is it clear or not?
Yes, sir. Clear.
Yes, sir.
Okay. Now we'll go to the next slide. And now you can solve it, resolve it, please. Everybody resolve it. Please resolve this given question so that you get the value, you can get the idea that how to find out the moment or distributed moment in adjacent members. Please solve within the next 5 minutes.
Yes, sir.
Okay.
सर एक और स्टूडेंट है, शायद उसका भी इंटरनेट का इशू आ गया था, वो कह रहे हैं कि एडमिट करते हैं।
मैंने कर दिया जी, अभी 2 स्टूडेंट थे इस लॉबी में, मैंने ऐड किया।
ओके सर, थैंक यू।
पता नहीं आई थिंक प्रॉब्लम है इंटरनेट का. Now we'll move to the next step now. Should I move on? ये क्लियर है जी कैसे आप डिस्ट्रीब्यूटेड मोमेंट फाइंड करेंगे?
Yes, sir.
So now we'll move to the next part. Then comes the relative stiffness factor. This relative stiffness factor is basically stiffness factor relative to the other members actually. So if all the members are connected in one joint and the far end for the members is equals to actually a fix, so then you can say that the relative stiffness factor is I over L. If condition is if that the material or modulus of elasticity for all the members is same, E value is same. So then 4E I over L, this I over L, it will remain as I over L. So it will be called as relative stiffness factor now. So this term will be very rarely used in the exam in this methodology, but we should know that what is the stiffness factor for this member and this relative to each other. Then comes carryover factor. This is the second important, most important you can say term we should remember for this methodology of moment distribution method. So carryover factor is a factor through which moment is carried over from one end of the span to the other end of the span. So this is the pure definition, you should remember that. How much movement can be carried over from one end of the beam or one end of the panel to the other end or far end of the panel? हम कितना movement एक end से दूसरे end पे लेके जा सकते हैं? Is it clear?
Yes, sir.
Is it clear, students? समझ आई है जी कि नहीं? That the
Yes, sir.
distribution factor is the factor through which moment is distributed from joint to the adjacent panel, from joint to adjacent panel, from joint to adjacent panel. How much will be distributed to adjacent panel? But whereas carryover factor is the factor through which moment will be transferred from one end of the beam to the other end of the beam. We'll find out that this much of the moment. समझ आई है जी कि नहीं?
कंप्यूटर जो चलाओ करना है
You got it or not?
लैपटॉप पे ना माइक मेरा ऑफ है माइक देखो मतलब लैपटॉप से माइक ऑफ है मेरा हैंड पे चल गया लेकिन माइक नहीं चल वो माइक वो ही ऑन करना है मतलब कंप्यूटर मेरी सारी क्लासेस लग गई हैं
And how much movement will be transferred from one end of the beam to the other end, far end of the beam. So we will apply slope deflection equation in this span. We know that the slope deflection equation is MAB 2EI over L into 2 times theta A plus theta B minus 3 psi plus fixed end moment. So we know that theta B is equals to 0. Theta B is equals to 0. Psi value is also equal to 0. Then moment, fixed end moment due to the end is also equals to 0. So this M is equals to 4EI over L into theta A. Now if we apply the slope deflection equation for this part, so that will be equal to MBA equals to 2EI over L into 2 times theta B plus theta A minus 3 psi plus fixed end moment at BA. So if we solve it, we find that the value for M dash is 2EI over L. So this is 4EI over L. This is 2EI over L. So if we get the relationship, we find out that M dash is equals to 1 by 2 of M. So it means from this end to fixed end, from this end to fixed end, from one end of the beam, from this end of the beam, whatever is the moment over here, its half can be carried to the far end. Let's say over here we have 10 kilonewton meter. So we can carry over here as 5 kilonewton meter if this if is very important, if our far end is fixed. इस चीज की समझ आई है जी कि नहीं? You got it or not? That this half is our carryover factor. This plus 1/2 is our carryover factor. But it prevails, it will be used only and only if our far end is fixed. If we have fixed end, then we can use this. Then we can use as carryover factor if our one end of the beam is fixed. Then we can carry the moment from one end of the beam to the other end of the beam. स्टूडेंट समझ आई है इसकी कि नहीं जी?
यस सर आ गई.
क्लियर है? Everybody, is it clear?
Yes, sir.
Okay. So it means if I ask you, let's say if this is the case, this is hinge on one side, this is also hinge on other side. So how much movement will be carry over from one end of the beam to another end in this case? Can anybody tell me?
सेम होगा.
बिल्कुल. आपका रोल नंबर क्या है बेटा? वेरी गुड हमजा. So once your support is hinge, it cannot resist, it cannot take any moment. We know that hinge or roller, they cannot take any moment. Moment at these points is equals to what? 0. So here the moment is normally 0, isn't it? ऐसे नहीं है जी?
Yes sir.
Yes, sir.
So once the moment is 0, we cannot carry the moment to that particular support. So in this case, our carryover factor will be also equal to 0. We cannot transfer the moment from one end to the hinge actually. Clear? So we cannot transfer the moment in this. But whereas if we have a fixed end at the end, we can carry half of the moment to other part actually. Clear? Is it clear or not?
Yes sir, clear.
Okay, now we'll move to the next part. Then is this 3EI over L. Already told you that if our far end is hinge, our value of stiffness is 3EI over L. This is what I have already told you once we were discussing it in the stiffness part. So then there is some important cases. So this one we have already discussed, that carryover factor will be equal to 0 if our far end is hinge or pin. Okay, if our far end is hinge or pin, we will consider that our carryover factor is equal to 0. Will not consider any moment. Then there are two special cases we need to consider for the distribution factor. This is one case number 1 and the second one is case number 2. So it will come like, let's say if you have a continuous beam, something like this. So let's say over here you have hinge, and over here you have fixed. In between, let's say you have rollers, you have again hinge. So here you can find out the distribution factor at this end very easily, that whatever the stiffness over here, whatever the stiffness over here, their total sum, and you can find out distribution factor. But at this joint, but on the far end joint, if we see that at this joint, you know the stiffness at this part, but what is the stiffness on this end? Can anybody tell me? What is the K value for this other side? So this K value is infinite. There is infinite stiffness on this side of the beam. Once there is a fixity, this K value is infinite. But whereas this stiffness we can find out. So something over infinity, the distribution factor is 0. So once we have any structure like this, the distribution factor for this support that is equals to 0, it should be, remember this is special case. Now same is over here. We know the stiffness at this side of the beam, but the stiffness on the other side is equals to 0 because this beam can rotate about this particular point. So we say that the stiffness on the other side is equals to 0. So this will be equal to KAB divided by 0 plus KAB. So the distribution factor for AB will be equal to 1. So it means we should remember, or we should keep this thing in our mind, that once our last end of the beam is fixed, our distribution factor will be equal to 0. Whereas if our far end is hinged, our distribution factor will be equal to 1. Is it clear, students?
Yes, sir.
What's your roll number, gentlemen?
Sir, 103.
103. यार ये 5-4 बच्चे ही हैं कि बाकी भी हैं? मुझे तो आवाज ही नहीं आती बाकी.
Sir, you repeat कर दें please.
Okay, I'll repeat it again. So I repeat again, there are two special cases for the distribution factor. One case is that if your last support is fixed, then your distribution factor will be equal to 0. Why? Because the stiffness on the other side of the beam is equals to infinite. Here, if you see, if your far end is hinged, this is last end, if your beam is ending over there and the last support is hinged, in that case our distribution factor is 1. We find out that this is our distribution factor, that is equals to 1. So these two cases you should remember while solving any problem using moment distribution method. Clear?
Yes, sir.
Okay. Now what is the procedure of analysis? There is a 4-step procedure for this method. Number 1 is that we will consider that all the joints are initially locked and we will find out fixed end moments. So you remember this step we were doing actually in our slope deflection method as well, if you remember, students. आप लोगों को याद है कि यही स्टेप हम वहां पे करते थे, हम initially we find out fixed end moment in our slope deflection method as well. Same we are going to repeat here. Then second is at each joint find out unbalanced moment. So we will find out what is the balancing or unbalancing moment over there. Then determine the moment, and that is need to put on each joint. So means we will find out counterbalancing moment. So step 2 is this one. We will find out counterbalancing moment. Then we will distribute this counterbalancing moment to the connected spans according to distribution factor. This is called as unlocking of joint or release of joint. So this is the second step which we just exercised. जो भी आप लोगों ने distribution factors calculate किए. So all the factors you have calculated, actually this is our step 3. That you will find out the unbalancing moment and then you are going to distribute it. And next step is you will carry the moment in each span from one end to the other end. So this is the methodology we will follow. Number 1 is here you will find out distribution factor apply, and here you will apply carryover factor. And again you will keep on repeating this procedure. Unlocking, locking of the joint, unlocking, locking of the joint, until unless you find out that the moment at each span or end of the joint is approximately equal to 0. So how we proceed, we will solve it in the examples. Is it clear, students, about the theory?
Yes, sir.
Yes, sir.
You got the theory,
Yes,
that
sir.
there are two major things in this method. Remember, there are two major things in this method. If you don't understand them, you cannot solve any question with the procedure of moment distribution method. Number 1 is you should know what is distribution factor. And number 2 is you should know what is carryover factor. Can anybody tell me what is distribution factor?
Sir, the portion of total moment which is transferred or distributed to a particular member.
जी आपका बेटा नाम और रोल नंबर
Sir, 103 Muhammad Uzair Shafi.
Okay. Anyone else who can tell me carryover factor?
Sir, factor
जी जी सॉरी आपकी आवाज नहीं आ रही बेटा
factor through which movement is carried over.
आपका रोल नंबर बेटा जी 86 Mubin Hassan. Okay. Anyone else who can explain?
Sir, how much moment is carried from one end to other end?
How much movement is carried over from one end to again Uzair you are answering I think.
सर जो एक जॉइंट पे हमारे पास मोमेंट होता है वो मेंबर्स तक को डिस्ट्रीब्यूट करना
उसको डिस्ट्रीब्यूशन फैक्टर कहते हैं
यस सर
आपका रोल नंबर बेटा
ओ सर फैसल रोल नंबर 81
okay Faisal. Anyone else who want to explain something? Remember I have marked you but I'm now seeing the presence of the students in the class. This is more important than your attendance actually to me. Roll number 67, can you explain this carryover factor? Okay. Now I'll go to the example now. So let's say this is a 3-span beam given to us to find out or to find out its internal moments at each support, to draw its shear force bending moment diagram. So our step 1 in this beam is to find out fixed end moments. You see these fixed end moments. What will be the fixed end moments over here? What will be the fixed end moments? Anybody who can answer? What will be the fixed end moments within the span AB? Anybody who can answer?
Sir, 0.
0. Why?
0.
Sir, load ही नहीं है.
No load is applied. So if we go to this span, one moment over here, one moment over here now. And we go to this span, one moment over here, and one moment over here. Clear? So now we find out, we saw that if it is counterclockwise, that will be negative. If it's clockwise, then it is positive. So you see, this moment is negative, this moment is positive. Similarly over here, this is counterclockwise negative, this clockwise is positive. So this is our step 1. And this is, I think, same step we have done in slope deflection method. Isn't it?
Yes, sir.
Yes,
same.
तो कोई फर्क नहीं है अगर आपको स्लोप डिफ्लेक्शन आता है तो आपका ये 2 नंबर का क्वेश्चन यहीं पे ठीक हो जाएगा मोमेंट डिस्ट्रीब्यूशन मेथड में. Now next step is you will find out the stiffness factor for each member. KAB, KBA, KBC, KCB, KCD and KDC. So as in this case of beam, all the far ends are considered to be fixed. So if you see, the stiffness factor is 4EI over L. Stiffness factor for each member is 4EI over L. Now there will be a question in your mind, I think it should be as well, that these supports are roller, isn't it? These supports are roller, but still we are considering that the stiffness is 4EI over L. Isn't it?
Yes, sir.
Sir, intermediate sports हैं इस वजह से.
बिल्कुल. So we have already discussed it by the way as well, that these supports are interior supports, internal supports. So we consider them as actually fixed supports. So that's why over all the stiffness factors for each span. So it means this is our span. One stiffness factor over here, one stiffness factor we are calculating for the other part. This is KBA and KAB, remember. This is how we are calculating it. So we have calculated the stiffness factors. Then we will find out distribution factor. How many distribution factors we will calculate? How many distribution factors?
2 sir.
जितने joints हैं, remember this joint,
4 sir.
this joint.
4 sir, 4.
So we will find out 4 distribution factors. So the distribution factor for this first support, for this support, this will be equal to 0 because of it is our fixed support. So why it is 0? Because the fixity on the far end of the fix, the stiffness of the far end of the fix is infinite. So this case, just we have discussed this one.
एक्सक्यूज मी सर
जी जी
सर एक स्टूडेंट है उमर मलिक, वो कह रहा है कि एडमिट कर दें.
ओके. Now if we find out the distribution factor for joint A, that is equals to 0, but the joint B distribution factor is 0.5 and 0.5. How we calculate? That whatever the stiffness factor over here, what is the stiffness factor over here? So the distribution factor actually for BA will be equal to the stiffness of BA divided by the total stiffness of the joint. If you remember just a while ago, about 10 minutes back, what we have calculated, what we have discussed, now we are using it in the calculation of question. We are calculating the distribution factor for each joint. So for this joint, how many distribution factors? Can anybody answer? How many? G? BA and BC. Distribution factor BA and distribution factor BC. Let's say there is one more member. I'm giving, let's say if there is one more member like this. So then there should be one more distribution factor actually. Clear? If it is the case,
Yes, sir.
You need one more distribution. Let's say there is one more member, you will use one more distribution factor. But remember, the total distribution factor of the joint should be equal to what?
1, sir.
1. Clear? So if you see over here, this is what we have calculated distribution factor for joint CB, and then we have calculated the distribution factor for joint C. And then at the same time, the distribution factor for the last part is also equal to 0. So this is the part actually we discussed in our lecture, and now we have applied all these members, all these steps on the continuous beam. So you see, if we go, we have found that this is stiffness, this is our step 2. Then this is step 3 to find out the distribution factor. So this again we have this exercise in the discussion of our lecture. Clear? Is it clear or not?
Yes, sir, clear.
ये वही चीज है जी जो अभी 2 मिनट पहले हमने पीछे सारी डिस्कस की है, and the same thing we are applying on the question now. Clear? Is it
Yes,
clear?
sir. Clear.
Yes, sir.
Yes, sir.
I will stop here. I'll not go to this part, which is slightly tricky. Although I can explain you, but it will make you confused. What I want actually you exercise that how to find out stiffness factors and how to find out distribution factors. This is important. Then next is nothing actually. We are just to apply this locking and unlocking of the joints. But I can explain what we will do. You can draw the beam, and underneath beam you can write down joint, you can write down member, and then you can write down distribution factors. So this is, and also you can write down fix and moments. until this value. This is what you have already gathered. These 4 lines, the data you have already calculated. You know what is the joint? Joint is A. You know what is the joint? Joint is B. You know what is the joint? C. You know the joint is D. Then member, this is member AB, this is member BA, BC, CD. Okay. Then you know the distribution factors. You have calculated them. Distribution factor for AB equal to 0. So you put it here as 0. For this one, 0.5 and 0.5. For this one, 0.4 and 0.6. And then last one is also 0. Then you have calculated the fixed end moment. So the fixed end moment at this point equals to what? 0. Fixed end moment at this one equals to what? 0. Fixed end moment here is minus 240. And fixed end moment over here is plus 240. Fixed end moment at this end is minus 250. And fixed end moment over here is plus 250. So this is the red line or the red box I have plotted. This data you have calculated in your previous 3 steps. This is what I have written actually. Is there any confusion until now? Students, is it clear that this is the data actually we have plotted underneath the beam?
Yes, sir. Yes, sir.
Is it clear?
Yes, sir.
There's nothing until now. We haven't done anything, by the way. This is just the information we gathered in the last 3 steps. From here we got the fixed end moments, calculated these fixed end moments. So this is what we put here in this row actually. We found the distribution factors, we have written them. Isn't it okay?
Yes, sir.
यहाँ तक समझ आई है जी? Any confusion until now you can ask, I will repeat. Because until now almost half of the question is done. Please, if you have any confusion, students, please ask. No? Should I move on? जरूरी नहीं है बेटा, जरूरी नहीं है. अगर यही सपोर्ट आपके पास हिंज हो जाए या रोलर हो जाए, नहीं, लेकिन वो फॉर लास्ट सपोर्ट है ना, लास्ट सपोर्ट की बात. तो देन इट विल बी 3 EI over L. समझ आई? लेकिन इंटीरियर के लिए आप फॉर श्योर 4 EI over L चले. Anyone else who wants to ask something? Nothing ji. So should I move on? Please tell me. Ji, Hamza, are you there? Uzair?
Yes, sir.
Faisal?
Yes, sir.
Mubin, are you there?
Yes, sir.
Abdul Hasib? 69.
Yes, sir.
Then Farhan, 72.
Yes, sir.
Okay. Now, next step is very important. Remember why I stopped and I make the emphasize this is the information we got it. Now, next is you will find out that what is the unbalancing moment on the joints. Now, if you see, this is joint B with you. How much is the unbalancing moment on this joint? कितना unbalancing moment है यहाँ पे? So we have minus 240 kilonewton, minus 240 kilonewton meter. This is unbalancing moment, isn't it? ये वो moment है जो joint पे मौजूद है. We have a minus 240 kilonewton or counterclockwise moment is there, which is causing the joint to rotate counterclockwise. It is unbalancing moment available on this joint. So we should counterbalance it so that the joint should be in equilibrium. Clear? So our counterbalancing moment will be equal to plus 240. Again, we'll go to the joint C and we'll see that how much is the unbalancing moment at joint C? Can anybody tell me?
Oh, minus 250. नहीं, तो 10, yes, so 4 and 6 will be distributed.
Minus 10 is our counterbalancing moment. Minus 10 is on balancing moment. So it will be balanced by
4 and 6.
10 balancing moment. So this is the trickiest part within this moment distribution method, that you will find out counterbalancing moment at each joint. You calculated that here we need 10 kilonewton, which is counterbalancing. Here we need plus 240 as counterbalancing. Now, this 240 is our actually moment at this joint, which should be distributed to the ends. How we will distribute now? Can anybody tell me? कैसे इसे डिस्ट्रीब्यूट करेंगे?
सर वो फैक्टर जो हमने ऊपर निकाला हुआ है डिस्ट्रीब्यूशन फैक्टर
मल्टीप्लाई बाय दिस प्लस 240 with multiplied with 0.5, and you see here it is written as plus 120, and here is also it is 120. So you got from where this 120 comes out. समझ आइए कि ये plus 120 कहाँ से आया है? And similarly over here we got 4 and 6. Is it clear?
सर ये रिपीट कर दें.
मैं कर देता हूँ जी, मैं कर देता हूँ. So I repeat again. I'll discard this and I'll repeat it again. If you see over here at this joint B, our unbalancing moment is minus 240. So to counterbalance it, we need plus 240 moment, which is required for equilibrium. This plus 240. Here unbalancing is minus 10. So we need plus 10 to keep the equilibrium. Clear? So this plus 10 will be now distributed because this is the unbalancing moment over here in the beam, that is equals to 10. Here we have about counterbalancing of moment, that is 240. So this will be distributed based on distribution factor. So the distribution factor here is 0.5, 0.5. So it means 120 will go to this end and 120 will go to the other side of the panel. Here we have 10, so 4 will go to this end and 6 will go to the other end. If you see over here, it is 4 and 6, 120 and 120. This will be our distributed moment. If you see, it is written over here, and we have seen its definition again and again and again, that moment that is distributed from joint to adjacent panel. Moment that is distributed from joint to adjacent panel. समझ आइए जी कि नहीं? Got it or not, guys?
Yes, sir.
Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
This is our distributed moment now. Once you have got the distributed moment, now you will carry over it. So this distributed is over here now. This is 120. It will be carry over to the side support as 60. So this is what we have done actually. We have carry over to the adjacent panel. So what we got here, that was 120. So this will be carry over to the other end. We have got 4 over here that will be carry over to the other side. So if you see, it is 2 over here, it is 60 over here, and then we got 6 over here, which will be carry over to the other side as 3. Clear? Now it means you will do, first you will perform, you will find out unbalancing moment over here, you will counterbalance it, then you distribute and carry over. Then over here you will put again a line. Now again you find out what is the unbalancing moment at joint B. This is joint B now. What is unbalancing moment at joint B now? कितना unbalancing moment है जी joint B पे? 2. So इसको balance करने के लिए कितना moment चाहिए? -2. So this will be -2. Now, so if you see over here, how much is the unbalancing moment here? 60 plus. So we need -60 to counterbalance it. So this minus 60 will be distributed now. So you see this is distributed, and again it will be carryover. So this procedure is going on now. Then in next step you go distribution carryover, distribution carryover, then last distribution, and you find that this distributed moment over here at the end of the joint, this end of the joint, if this distributed moment is approximately equal to 0 with respect to the initial value, that initially you got it as 240. So this 240 is now reduced to 0.3. And here we have a total unbalancing as 10. So this has reduced to 0.01, approximately equal to 0. We stop here and then we find out and we sum the values that what we are getting over there. So we sum these values, values which are over there as carryover moments, and these carryover moments we sum them up and we find that this is 62.3. Then we add these values over here and we find out that this 120 plus 6 minus 1.3, and then you find out the value, and this similarly you sum these values, sum them up, and this is your end moments of the span. So this is what we are going to find. We find the values. What is the moment here? What is the value here? What is the value here? What is the value? So if we can find out internal moments, we can find reactions. We found the reactions. You can draw shear force and you can draw bending moment diagram. The rest of the procedure is same once you find the end moment. Is it clear? Class, is it clear?
Yes, sir.
Yes, sir.
So you see, only thing which we need to do, we need to find out or we need to understand two mechanisms actually, how to distribute the moment and how to carry over. So for the distribution, we find out that this is our counterbalancing. So this counterbalancing will be distributed. Then after distribution, carry over. Again, once you have done the carryover, you find out that this is our counterbalancing. This is our counterbalancing. Again, you distribute it and you carry over it. Then you distribute it and you carry over it. You distribute and you carry over. So this is the way you can maybe go on, and maybe you go another step after this. You can do another step after this. This is very easy. You can go by this. Doesn't matter. But ultimately, your results will be more refined actually. This moment will be more refined. But as we see over here, we have already approximately equal to 0 value. So we stop over. That's why it is called as method of successive approximations. So we are going with the distribution carryover, distribution carryover, distribution carryover, unlocking, locking, release and joints. This is how we are solving the question. Is it clear, class?
Yes, sir.
Yes, sir.
So this is what I
Yes,
have
sir.
all for today. Next time, inshallah, we'll try to solve few more examples. We'll try to solve few more examples of this moment distribution method. And I'll also try to ensure, inshallah, to give you the recorded video of the previous sway frames. This is what is missing over there. And inshallah, we'll discuss in the next class this moment distribution method, and it will also be finished in the next week, inshallah. So if you are have understood, everybody, you can leave the chat room. So this is what all I have for today.